Hello students, welcome you all. So today we are going to discuss exercise 13.3. So let's start. Question number 1. A metallic sphere of radius 4.2 cm is melted and recast into the shape of a cylinder of radius 6 cm. Find the height of the cylinder. So here you see there are two objects, one is sphere, another is cylinder, and the volume of two objects will be same. So let's start. Here radius of sphere is equal to, you can say 4.2 r1, you can say r1 equal to 4.2 cm. Well, and here there is a cylinder, so let radius equal to it is 6 cm. Here r2 you can write r2 equal to 6 cm. We have to find the height, so you can write height equal to, you can say h. So here volume of the sphere will be equal to volume of the cylinder, you can write it volume of sphere equal to volume of cylinder. So volume of sphere, you know, pi 4 by 3 pi r cube. So here r is r1, so you can write r1 cube will be equal to volume of the cylinder. So volume of the cylinder is pi r square is pi, r is here for volume r2 square, h is h. So here you can cancel the pi, then you can write 4 by 3 into r1 cube. R1 is 4.2, so 4.2 cube, you can write 4.2 into 4.2 into 4.2, which will be equal to r2 square into h. So r2 is 6 here, so you can write 6 square or 6 into 6 into h implies. So here you can cancel some you can cancel 3 and all these things, then finally we can find h will be equal to okay, we cancel it 3 3 1 1.4 it will be, then similarly you can cancel 3 6, you can cancel 6 0.7, here this 6 will be cancelled with 0.7. So h will be equal to 4 into 1.4 into 0.7 into 0.7. So it will be equal to 2.744. So this will be your answer. H is equal to 2.744. Now I'll move to the next question. Here it is. A metallic sphere of radii, a metallic sphere of radii 6 cm, 8 cm and 10 cm. So metallic spheres, there are suppose 3 metallic spheres, 6 cm, 8 cm and 10 cm radii, now are melted to form a single solid sphere. So we have to melt all these 3 metallic sphere and we will make another large metallic sphere. Find the radius of the resulting sphere. So what you can see, there are 3 metallic sphere. So you can write radius of first sphere is equal to r1, you can say r1 equal to 6 cm. Similarly, radius of the second sphere is r2 equal to 8 cm, and similarly r3 is the radius of the third sphere will be equal to 10 cm. Now you have 3 spheres, radius are given, and radius of the fourth sphere, that is the resultant sphere. Let write radius of resulting sphere. equal to say bigger. Now volume of the sum of the volume of the three sphere will be equal to volume of the resulting sphere. So we can write pi 4 by 3 pi rq, that is r1q, plus 4 by 3 pi r2q plus 4 by 3 pi r3q. So 4 by 3 pi rq is the volume of the square, will be equal to 4 by 3 pi large rq. Okay, implies now you can take 4 by 3 pi common from these three terms. So 4 by 3 pi you can take common, then r1q plus r2q plus r3q, which will be equal to RHS is same 4 by 3 pi large rq. Now you can cancel 4 by 3 pi and 4 by 3 pi in the LHS and RHS. So which will be equal to r1q plus r2q plus r3q. Now you can put the value. R1 is a 6q plus 8q plus 10q will be equal to rq. Now implies r will be equal to qth root. Qth root of 6q is your 216 plus 8q is your 512 plus 10q is your 1000. So which will be equal to qth root of, now you add all of them, this it will be 1728, then it will be equal to 12. Okay, so this is your answer. Now we will move to the question number 3. A 20-meter deep well with diameter 7 meter is dug and the earth from digging is evenly spread out to form a platform 22 meter by 14 meter. Find the height of the platform. So here you see there are two things. One is well, another is another platform of length 22 meter and breadth 14 meter. So situation is here like this. There is a well. Okay, what are the dimensions of well? Here radius r is given, diameter is 7, so r will be 7 by 2, and height or depth of this well is 20 meter, so h equal to 20 meter. Now this is 7 by 2 meter. Well, this soil, this earth is to be placed on a platform like this, and length of the platform is 22 meter, breadth is 14. So here 22 meter and 14 meter, and this will be put here on this platform. So a height must be there like this. So height we don't know, let the height be h. Okay, so what the situation is here? The situation is here, the volume of this soil will be equal to volume of this well. So let's write that here, volume of well equal to volume of earth or soil, you can write. Implies here volume of this well will be equal to pi r square h, it is a cylinder, so you can write pi r square h is equal to volume of the soil. So what will be the volume of the soil? You know that this set is in a shape of cuboid. Now length and breadth you have, we don't know the height, so we can write length into breadth into height. Implies now we know the values, you just put the values. Pi is value is 22 by 7 into r, you have r 7 by 2, so you can write 7 by 2 into 7 by 2 into h is your 20 equals to length into breadth into height. Length is 22, breadth is 14. So like 22 into 14 into height. So here you can cancel this 7 and 7. You can cancel the 22 with this 22, and also you can cancel this 7 by this 14. 7 to the 14. Now you have 2. You can cancel the 2 with this. It will be 10. So you can cancel the 2 with this. It will be 5. Now you have h equal to 5 by 2. Implies h equal to 5 by 2, which will be equal to 2.5 meter. So who is h? H is the height of the soil. So you can write height of the soil is 2.5 meter. Well, now we'll move to the next question. A well of diameter 3 meter is dug 14 meter deep. So here you can see in the figure, a well is there and the depth of the well is 14 meter, okay, and diameter is 3 meter. The earth taken out of it has been spread evenly all around it. All around means all around the well in the shape of a circular ring. So you can see the earth is around the well is in a shape of circular ring of width 4 meter. So this width, you can see this width is 4 meter. To form an embankment, find the height of the embankment. So you have to find this height. So you can see this embankment is also in the shape of a cylinder. The well was already in the shape of cylinder. Now the embankment is also in the shape of a cylinder. Now we will write what are the data that are given. First thing, diameter of the well is given. So we will write radius of well equal to, you can say, R1. So R1 is equal to 3 is the diameter. So radius will be 3 by 2. 3 by 2 meter. Then height of well. Height and depth are the same thing. Height of the well is equal to, you can write H1 equal to 14 meter. Then we'll move to the embankment. Outer radius. So you can say radius is 2 radius. This embankment has 2 radius. That is, one is outer radius and inner radius. So outer radius of embankment is equal to, you can say, R2 equal to, you have this length is 4, so therefore it will be 3 by 2 plus 4, which will be equal to 11 by 2 meter. Similarly, you can write inner radius of embankment will be R1 itself. Inner radius is the same, which is equal to 3 by 2 meter. Then height of embankment will be equal to, say, suppose H2. H1 was here our height of the well. Now what will be there? The volume of the well will be equal to volume of the embankment, as the earth dug from the well has been put on the embankment. So we can write volume of well equal to volume of embankment. So volume of the well will be equal to pi R1 square H1 will be equal to volume of the embankment. Here we have 2 radius, so it will be pi R2 square H2, that is the outer diameter, minus pi R1 square H2. Now implies, here we will write the same, pi R1 square H1 is equal to, you can take pi and H2 common, pi H2 into R2 square minus R1 square. So you can cancel the pi and pi here. Implies, now we will put the values. So r1 is your 3 by 2. 3 by 2 square means 3 by 2 into 3 by 2 into h1. H1 is your 14 into 14 is equal to h2. H2 we don't know the value of h2, that is what we have to find. H2 into r2 square minus r1 square. So r2 is your, here we have r2 here 11 by 2. So 11 by 2 square minus r1 square. R1 is your 3 by 2 square. Okay, implies here you can cancel this 2. This will be 7. So 7 into 3 into 3, it will be 63 by 2 will be equal to h2 into 11 square by 2 square will be 121 by 4 minus 9 by 4. It will be equal to, here 63 by 2 will be equal to h2 into 121 minus 9 will be 112 divided by 4. Now you can cancel this. 28 now implies h2 will be equal to 63 by 2 divided by 63 by 2 into 28. So which will be equal to, you can cancel it side, 7 7 9 7 4, so 9 by 8, which will be equal to 1.125 meter. So this will be the height of the embankment. So h2 or height of the embankment is equal to 1.125. So this is your answer. Now let's move to the next one. Question number 5. Here you have a container spread like a right circular cylinder having a diameter 12 centimeter and height 15 centimeter is full of ice cream. Okay, the ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter. Very nice. Having a spherical shape on the top. Okay, so there are two things. One is a cylinder whose dimension are, diameter is 12 and height is 15 cm. We will write that. So radius of cylinder, diameter is 12, so radius will be equal to, we can write radius cylinder is equal to r1. R1 equal to 12 by 2, which is equal to 6 centimeter. Height is given, so you can write height h1, you can say h1 equal to 15. Okay, now this cylinder has full of ice cream and that to be filled in another ice cream cone whose dimensions are given. So first we will find the volume of the cylinder. So volume of cylinder equal to pi r1 square h1, which will be equal to pi r1 is 12 by 2, 6 square into h1 is 15, so which will be equal to 540 pi. So pi, this will be your centimeter cube. So this will be your volume of the cylinder. Now we will move to the cone part. Here you can see the ice cream is to be filled in a cone. The height of the cone is 12 centimeter and diameter is 6 centimeter. So we will move to the cone. Now radius of cone is equal to, you can say r2. Okay, which is equal to 6 by 2 equal to 3 cm. Again height of cone equal to say h2 S2 is equal to 12 cm. So volume of the cone you can write volume of cone will be equal to, you know the volume of the cone is 1 by 3 pi r square. H, who is r is here r2, h is here s2, so r2 square and s2 square you can write, which will be equal to 1 by 3 will put the value into pi will write the pi, r2 is your 3 square into h2 is your 12, so it will be equal to 3 will be cancelled, 12 into 3 36 pi cm cube. So this is the volume of cone. Again you see, having a hemispherical shape on the top, so there is a the cone is there, okay, the cone has a hemispherical top. Now the radius of the hemisphere will be same as the radius of the this cone, so you can write radius of hemisphere, you can name it r3, which is equal to same as the radius of the cone, so it is equal to here you have 3 cm. So volume of hemisphere is equal to, you know the volume formula for volume of the hemisphere, it is 2 by 3 pi r cube, who is r is r3, so it will be equal to 2 by 3 pi r3 is 3 cube. Now you can cancel 1 3, so 3 3 is 9 into 2 18 pi, so it will be equal to 18 pi cm cube. So this will be the volume of the hemisphere. Now you can find the volume of the total ice cream. Now volume of ice cream cone, you can say ice cream cone is equal to volume of the cone, this volume, plus volume of the hemisphere, so 36 pi plus 18 pi, which is equal to 54 pi. So this is the volume of the ice cream. Now what we have to find the number of such cones which can be filled with ice cream. Now the total volume of the cylinder we have already found. How much? Here we have found. Now we have found the volume of one cone. How many cone can be filled? So you can write number of cones. Number of cones is equal to volume of the cylinder divided by volume of the ice cream. Volume of cylinder divided by volume of one ice cream. So which will be equal to, we have volume of this is your volume of the cylinder is 540 pi divided by volume of one cone is equal to 54 pi. Now you can cancel the pi, it will be cancelled, it will be equal to 10. So how many number of cone can be filled with one cylinder of ice cream? 10 number. So here answer will be 10. Now we will move to the next one. How many silver coins 1.75 cm in diameter and thickness 2 mm must be melted to form a cuboid of dimension 5.5 cm, 10 cm and 3.5 cm. So here you can see some silver coins are here like this. Okay, so these silver coins must have a radius. Here we have given the diameter, so we can find the radius, and it is a thickness, so the thickness will be the height. Now you can say the silver coin is in the shape of a cylinder. Now these are to be melted and to form a cuboid of dimension, length, breadth and height are given. So we have to find the number of silver coins. Okay, so the volume of the silver coin that we have to find, and we have to know the number of silver coins, that will assume as n into volume of the silver coin will be equal to volume of the cuboid. So let's start. Here radius of coin is equal to 1.75 cm is the diameter. So 1.75 divided by 2, which is equal to 0.875 cm. Again, thickness is given, but you remember here thickness is in mm, so you have to convert it into centimeter. Thickness, or you can write it height equal to 2 mm, which is equal to 2 by 10 cm, or you can write 0.2 cm, or whichever you can write. Now let's assume the number of silver coin be n. You can write let the number of coin is equal to n. Therefore volume, so you can write volume of n number of coin is equal to volume of cuboid, isn't it? Implies, now we can find the volume of coin first. So n number of coin will be n into pi r square h. Pi r is your 0.875 square into h, height is your 0.2, which will be equal to volume of the cuboid. So you can say length into breadth into height. Implies, now we'll put the value, we don't know the value of n into pi value you can put, pi is your 22/7 into, you can write 0.875 into 0.875 into 0.2, you can write 0.2 also, is equal to length, breadth and height. Length is your 5.5 into 10 into 3.5. Now you can cancel them. Here you have 7 can be cancelled, 7 1, 7 2, 7 5, okay, 0.125. Now you can cancel, okay, 7, 0.5, here you can cancel 7, 0.125. Okay, after cancellation you please cancel all of this. It will be equal to, n will be equal to 400. I am not cancelling it here. So n will be equal to 400. So that how many number of coin you require to make a cuboid with this dimension? 400 number of coins. Okay, so this is the solution. Now we'll move to the question number 7. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter. So you can see a cylindrical bucket whose height is given 32 and radius is 18 centimeter. Is filled with sand. So this is filled with sand. The bucket is emptied on a ground and a conical heap of sand is formed. So this bucket is emptied here and you can see a conical heap is being formed. If the height of the conical heap is 24 cm, so you can see the height, this is the height is 24 cm. Find the radius and slant height. So you have to find the radius and slant height of this conical shaped heap. So let's start. Here what are given? Given is radius of cylinder equal to, you can say r1 equal to 18. Height you can say h1, which is equal to given 32 cm. This is also cm. Then you have a cone. So radius of cone equal to r2, which is not known to us. Height of cone H2 is equal to 24 cm. Slant height not given. You can write L. So you know that volume of the cylinder will be equal to volume of the cone. You can write it. Volume of cylinder equal to volume of cone implies volume of the cylinder formula you know, pi r1 square h1 will be equal to volume of the cone is here 1 by 3 pi r2 square h2. Here you can cancel pi, then we'll put the values. R1 is your 18 square into h1 is your 32 is equal to 1 by 3 into r2. You don't know the value of r2, just write r2 square into h2 is your 24. You can cancel this with 8, then you can cancel the 8, here it will be 4. Now implies r square equal to 18 square into 4, r2 square equal to 18 square into 4 implies r2 is equal to root over of 18 square into 4. 18 square root over is 18, 4 square is 2, so it will be equal to 18 into 2, that is 36 cm. So you have got the value of r2, that means this length is 36 you have, and you have the height, this height is 24. You can find the value of L. So now L is equal to root over of r2 square plus h2 square, which is equal to root over of r2 is here 36 square plus h2 is here 24 square. Now it will be equal to, which is equal to 30 square 6 square will be equal to 1296 plus 576 root over. Now it will be equal to, we can add it 1872 root over, then it will be equal to 12 root 13 centimeter. So this will be the slant height. Okay, so this is the solution. Now we will move to the next one. Water in a canal 6 meter wide and 1.5 meter deep is flowing with a speed of 10 km per hour. How much area will it irrigate in 30 minutes if 8 cm of standing water is needed? So what is given here? There is a canal. You can imagine a canal. The canal is in the shape of wide and deep is given. There must be a length. So you can say the canal is in the shape of cuboid. Okay, and it is flowing at a speed of 10 km per hour. Very nice. How much area will it irrigate in 30 minutes? So let's write breadth of the canal. Breadth of canal equal to 6 meter. We can write it B. Breadth of canal is B. Then height of canal H, you can say H is equal to 1.5 meter. Here again speed is given. Speed equal to, speed of the water equal to 10 km per hour. That means 1 hour means 60 minutes. In 60 minutes water moves 60 minutes. In 60 minutes water moves how much? 10 km. You can write it in meter, 10,000 meter. In 1 minute water will move will be equal to 10,000 by 60. Then the water has been irrigated for 30 minutes. So in 30 minutes we will find water will move 10,000 divided by 60 into 30. You can cancel it. 2, it will be 5,000. So you can write it is equal to 5,000 meter. Okay, so in 30 minutes the water will move 5,000 meter. So this will be the length of this canal. Okay, so you can say length is equal to L, you can say, which is equal to 5,000 meter. Now you can find the volume of the water. So volume of water equal to L into P into height. So which will be equal to, length is given 6 meters, 6 into breadth is, okay, length is here we have found 5,000. So you can say 6 into 1.5 into 5,000. So 6 into 1.5 into 5,000. So which will be equal to 6 4 5 000 meter cube. So this is the volume of the total water. Now you see this water is being irrigated where? In the field. Okay, if 8 centimeter of standing water is being needed, so you can see volume of the water will be equal to irrigated area. Irrigated area into height. Suppose in this field the water is being irrigated. So irrigated area into the height. Here height is 8 meter, 8 centimeter. Okay. So we have to write it in meter. So into height implies you have volume of water, that is 45,000 meter cube is equal to irrigated area, we don't know, just write irrigated area into height is your 8 centimeter. So 8 centimeter you can write it in meter, 8 by 100 meter. Okay, now you can cancel them. So implies you can write irrigated area is equal to 45,000 into 100 by 8. Now you can cancel it, it will be 25, then it will be 2, again you can cancel it. After cancellation you will get 562500 meter square. So this is the irrigated area. Now 5 plus 62,500 meter square is the irrigated area. Now you know that 1 hectare, you can write, we know 1 hectare is equal to 10,000 meter square. So 10,000 meter square equal to 1 hectare. This much meter square will be equal to 5,62,500 meter square is equal to 562500 divided by 10,000 hectare. Now you can cancel two zeros, then it will be equal to 56.25 hectare. So this much is the answer. 56.25 hectare area will be irrigated with this much water. Okay, now we'll move to the last question. A farmer connects a pipe of internal diameter 20 cm from a canal into a cylindrical tank in her field, which is 10 meter in diameter and 2 meter deep. If water flows through the pipe at a rate of 3 km per hour, in how much time will the tank be filled? So let's try to solve it. See what is given here. There is a pipe. So radius of the pipe R1 you can say equal to 20 by 10, 20 by 2, which is equal to 10 centimeter. So this is the R1. The length of the pipe must be there. So you can say it height H1 you can say is equal to, we don't know the value, just put question mark. So H1. Then we have to see the tank here. The radius of tank R2 you can write is equal to 10 diameter, so 10 by 2, which is equal to 5 meter. So it is in meter, here it is in centimeter. Yes, and deep is 2 meter. So height here H2 is equal to 2 meter. Now both the volume must be same as the water is flowing through the pipe, okay, and the same water is moving into the tank. So the two volume must be same. Therefore we can say volume of the pipe, water in the pipe will be equal to volume of the tank. So you can say pi R1 square H1 will be equal to pi R2 square H2. You can cancel the pi, implies R1, you can put the value. R1 is 10 centimeter, so you have to write them in meter. 10 by 100 square into 10 by 100 again, into H1, we don't know value, just write H1, equal to R2 square. R2 is here 5, so 5 square you can write, into S2 is here 2. Now you can cancel 0 here, 1 0 1 0, again 1 0 and 1 0. Now implies H1 will be equal to 5 square is 25 into 250 into this 100 will be here multiplied, which is equal to 5000 meter. So who is H1? H1 is 5000 meter. That means the water has to move 5000 meter. So here H1 is equal to 5000. Now you can see move to the next part. Here the water is flowing at a rate of 3 km per hour. So the rate of flow you can write, rate of flow is equal to 3 km per hour. That means 3 km 3000 meter. 3000 meter moves in 60 minutes. Okay, 1 meter moves in 60 by 3000. Okay, then we have to find 5000 moves, 5000 meter it have to move. So 5000 meter moves in 60 by 3000 into 5000. Now you can cancel 0 0 0 and 0 0 0 here. 3 2, it will be 20. 20 into 5 equal to 100 minute. So 5000 meter it will the water will have to move in 10 minutes. So we need to find that in how much time will the tank be filled. So the tank will be filled in 100 minutes. So it's an easy question. Now it is being solved. Now you please complete the exercise and submitted in the group. Okay, thank you. My god.